this demonstration, we are going to look at cervical vertebrae. Now here we are looking at the first cervical vertebra, which is called atlas. This cervical vertebra is a key point where the skull is articulated with the rest of the vertebral column. Depending upon the moves or depending upon the movements which are necessary in the head, the vertebra is completely modified and it does not really look like any typical vertebra. The body of the vertebra is modified. We don't see much of the body of the vertebra left here. Instead, it has become more flat and has become very short as well. This is the ventral view of the atlas. We see the vertebral body has become very short and it is even in the form of flat lamina, and so it is called ventral lamina. The body is modified into ventral lamina. A little part which projects backward from the ventral lamina, it is the ventral tubercle. As we see the cranial view of the vertebra, in this cranial view we see the articular surface for the occipital condyle of the skull. From the dorsal view, we see the lamina of the vertebra is still there. The pedicular part is slightly extending more laterally, that is the pedicular part, but then everything looks like a broad lamina on the dorsal aspect. The transverse processes are completely modified. Those are not as thin and spreading out as we saw them in the typical vertebra, but here they are more flat, extending almost along the length of the vertebra, and that's why they are referred to as wings of the atlas. The wings of the atlas are one of the important landmarks which can also be palpated on the live animal, and you can palpate these edges of the wing of the atlas in the live animal. In the caudal view of the vertebra, we see another articular face or another articular surface which is for articulation with the body of the axis, which is second cervical vertebra. From the cranial view, we see the central vertebral foramen, which is as usual. Then we see there is in the lateral view, we see a foramen which is located right here. At the cranial end of the vertebra, a foramen is located which communicates the vertebral foramen to the exterior. And that foramina, one on each side, those are for passage of the first cervical spinal nerve. Then as we come a little bit more caudally, we see another foramen which actually runs or which is directed along the length of the vertebra, which is for the passage of the blood vessels through the wing of the atlas, and the vertebral artery and vein is going to pass through that foramen, so it is called transverse vertebral foramen. Transverse vertebral foramen on the other side, transverse vertebral foramen on this side. So we see the transverse vertebral foramina and we can see through them in this particular view. That is the caudodorsal view. I can see the transverse vertebral foramen. The caudal view of the bone, the dorsal lamina, the ventral lamina, articular surface for the body of the axis. At the cranial end again we see two notches. Those are called alar notches. So this is alar notch on the left hand side, that is the alar notch on the right hand side. Dorsal view of the vertebra or dorsal lamina of the vertebra, but the spinous processes are not present, and the cranial and caudal articular processes are also not present. One of the important features to notice here, the atlas does not have any cartilaginous articulation either with the skull or with the following vertebra. It is cranially articulated with the skull by means of atlanto-occipital joint, which is a synovial joint, and caudally to the axis, which is also a synovial joint. Along the ventral lamina, when we see it from the caudodorsal aspect, we see an indentation. That indentation is for the dens, which is part of the axis, which is going to protrude through the vertebral foramen. So this is for, or this indentation is for the odontoid process or dens of the axis. Okay, so these are the major features of the first cervical vertebra, which is called atlas, which is completely modified in order to provide articulation of the skull to the rest of the vertebral column. The second cervical vertebra, which is called axis. The cranial view of the axis bone or axis vertebra, the lateral view of the axis vertebra, the caudal view of the axis vertebra, dorsal part, the ventral part, the cranial view, the dorsal aspect and the ventral aspect of the vertebra. Now what we see here in the axis is the place where the vertebra is changing its shape back to the typical vertebra. So at the cranial end of the axis, that is the cranial end of the axis, we see the convex articular surface, and this is the body of the axis at the caudal end, which shows the concave articular surface. Okay, so let's go back to the cranial end. At the cranial end, the axis is articulated with the atlas, and so the moments which are present in this joint are quite different than what moments are further required between the axis and the third cervical vertebra and onwards. So here body is being transformed to a typical vertebral body at the caudal end of the vertebra, while at the cranial end of the vertebra it is modified to form a synovial joint. Now in this view we can see a small projection protruding forward even much beyond the body of the axis, that is called odontoid process or dens of the axis. That articular surface is going to fit into the caudal articular fovea of the atlas, which is meant for atlanto-axial joint. From the cranial view, again we see the body of the axis, arc of the vertebra, that is arc of the axis, and then we see the pedicle and the lamina. Along the midline, along the dorsal midline, the spinous process is present. The spinous process is flat and it extends all the way through the length of the vertebra. Even at the cranial end, it projects further beyond the body of the vertebra. It projects further beyond the vertebral arc. The dorsal view, cranial end of the vertebra, the caudal end of the vertebra. In the dog, nuchal ligament ends at the axis. It does not reach the skull, and so here we see some of the rough articular or rough area of attachment between the ligament and the vertebra. Okay, now let's look at the other processes and other structures which are associated with this vertebra. From the caudal view, some of the structures are now, we can see the transverse process, the caudal articular surface of the body of the vertebra, which is concave in nature, the caudal pedicular notch, the vertebral arc with caudal articular process, and the articular surface of the caudal articular process. Caudal articular process and the articular surface on the left hand side as well. The vertebral foramen. So when you look at the caudal end of the axis, it almost follows or it almost shows the structures which would be seen in any of the typical vertebra, except the cranial articular processes are not present because those are not needed. The lateral foramen is not present here because there is a space between the atlas and axis where the intervertebral foramen can be formed and the spinal nerve can come out through the intervertebral foramen. But we do have the transverse vertebral foramen, which allows passage of the vertebral artery and vein along the side of the vertebra. So this is your transverse vertebral foramen, which is very close to the transverse or which is at the beginning of the transverse process of the axis. The main feature of the axis is the dents or odontoid process. As we discussed earlier, we try relating the axis and the atlas and we try to put them in the order where they would be seen. The dents or odontoid process protrudes through the atlas and it almost makes contact with the skull bone.